Thank you very much. You're welcome back again. Please don't forget to subscribe. Hit that subscription, like, share, comment. Let us look at this simple probability. I say given that A and B are mutually exclusive events, these A and B are mutually exclusive events, such that probability of A is 0.5, probability of A union B is 0.9. We're supposed to find the probability of A complement union B. Then Roman 2, probability of A complement intersecting B complement. Then Roman 3, this is Roman 3. Probability of A given B complement. Let us look at Roman 1, not wasting time. We want us to get probability of A complement union B. For us to find this, it is true that probability of A complement union B is got by saying probability of A complement, okay, plus probability of B itself, then minus probability of A complement intersecting B. Probability of A complement plus probability of B, then minus the probability of the intersection of the two. But probability of A complement, we don't know it. It is not actually given, so we can find the probability of A complement. So probability of A complement is equal to 1 minus probability of A. And this one is 1 minus 0.5. This is 0.5 as well. 1 minus 0.5 is 0.5. So this probability of A complement is actually 0.5. Probability of B has not been given. We have to find it. Probability of A complement intersecting B has not been given. We have also to find it. So since A and B are mutually exclusive, it means the probability of A intersecting B is 0 for mutual exclusiveness. So we have to find that we can use from probability of A union B itself, because they gave us the probability of A union B. We have to use it. Will be equal to, this is the same as probability of A plus probability of B, then minus probability of A intersection B. So, but for mutual exclusiveness, then probability of A intersecting B is 0. For two events which are mutually exclusive, that means the probability of the intersection is actually 0. So therefore, probability of A union B becomes probability of A plus probability of B. Our probability of A is 0.5. Probability of B is not known. We are supposed to find it. Probability of A union B is 0.9. So we have 0.9 to be equal to 0.5 plus probability of B. So I can find out the probability of B from here. So therefore, probability of B would be 0.9 minus 0.5. This will be 0.4. This is probability of B. My probability of B is actually 0.4. The next is probability of A prime intersecting B. How shall we find it? We can go back and see how to find probability of A prime intersecting B. We can use the contingency table. It is not that A prime intersecting B. It's not that A prime and B which are independent. It is only A and B which are independent. So for us to find this, let's check on the contingency table. So we shall have some simple table here. I have this is A prime, and then I'll have B prime. So you see that this is going to be A intersecting B. This is actually A prime intersecting B, and this one is A intersecting B prime, and this one becomes A prime intersecting B prime. So if I want A prime intersecting B, A prime intersecting B is here. This is the same as actually getting the probability of B. So from probability of B equal to probability of A intersecting B plus probability of A complement intersecting B. But you see that probability of A intersecting B is 0 because of mutual exclusiveness. A and B are mutually exclusive. So therefore this implies that probability of B is actually equal to probability of A complement intersecting B, which is actually equal to 0.4. So we have found the probability of A complement, we know the probability of B, we know the probability of A prime intersecting B. So therefore, probability of A complement union B becomes probability of A complement is 0.5 plus probability of B 0.4, then minus 0.4 as well. So probability of A complement union B becomes 0.5. Yes, probability of B 0.4, probability of A complement times B is also 0.4, and the answer finally is 0.5. Let's come back. Roman 2. They need probability of A complement intersecting B complement. Now, your head must run very fast. A complement intersecting B complement. We cannot come and get it from here. We can get it from here, but it's going to be a long process. If you have to use the contingency table, yes, you're going to get the answer, but it's a long process. Because you're first supposed to find probability of A intersecting B prime using probability of A is equal to probability of A intersecting B plus this one, and then later you use this. It's a little bit long, but you're going to get the answer. But let's our head run very fast. Probability of A prime intersecting B prime is the same as probability of A union B, but is a prime out. That is the same as this. So therefore, probability of A complement intersecting B complement becomes 1 minus probability of A union B. Yes, as simple as that. So this one becomes 1 minus probability of A union B 0.9, and the answer here becomes 0.1. Probability of A complement intersecting B complement is actually 0.1. That one comes out simply like that. Let's move to Roman 3. We need probability of A given B complement. This is the same as probability of A intersecting B complement out of probability of B complement. Probability of A intersecting B complement, was it, did we get it somewhere? No, we have to find it. From the contingency table is here. We shall have that, but probability of, let me say from, not but, from probability of A is A, this one, want to get this, probability of A is equal to probability of A intersecting B, which is plus probability of A intersecting B prime. Remember, A and B are mutually exclusive, so meaning A intersecting B is 0. So this implies that probability of A is actually the same as probability of A intersecting B complement. So therefore, probability of A given B complement becomes probability of A. You can say just probability of A out of probability of B complement. So probability of B complement is not there, we can find it. So therefore, probability of A given B complement becomes probability of A itself. Probability of A is actually, we got it at 0.5. It is given the question, 0.5. Then probability of B complement. B complement becomes 1 minus probability of this one is 0.5. 1 minus 0.4. And this is 0.5 out of 0.6. This is actually 5 out of 10 times 6. I mean this becomes 10 out of 6. And then this becomes, the answer is 5 out of 6. So therefore, probability of A given B complement is actually 5 out of 6. Thank you very much.